Hello and welcome to this last and sixth feature engineering lecture in this course, Master in Artificial Intelligence. So in this lecture, we will take a look at an example of identifying and extracting meaningful features from a data set that can help you improve the performance of a machine learning model, right? And this is what we call feature engineering. So So let's take a look at example of identifying and extracting meaningful features from a data set. And here we have, let's consider a data set containing information about houses, such as features such as size of the house in square feet, the number of bedrooms, the number of bathrooms, the neighborhood, and the price of the house. And obviously, the goal is to predict the price of the house based on these features. So why the output is the price of the house, and the features are that is give data set that contains information is on size of the house in square feet, number of bedrooms, number of bathrooms, and the neighborhood, and also includes the price of the house. So you have all these five sets of data either in a data set that is available to you. Now, so how did the company start? So how did this was done in a company? Uh, so they started by creating a new feature by combining the size of the house with the size of the lot, if available, to present as available to represent the total area of the property. So they created, they were not given the total area of the property, they created this new feature. Then they calculated the price per square foot of the house, which was again not given, by dividing the price by the size of the house. And this captured the value of the house relative to its size and other features as well. Then they created a feature representing the age of the house, which was not there. So you see a lot of feature engineering happening here, right? So they created this feature called age of the house by subtracting the year built from the current year, right? And this would vary over the period as you go forward in future. Then they this encoded the categorical. The neighborhood was a categorical data, categorical input. They encoded that by using a technique like one-hot coding to represent each neighborhood as a binary variable, because that's what machines understand. Then they created interaction features such as product of the number of bedrooms and bathrooms to capture the combined effect of these variables on the house price, because that could you would guess that that is a critical thing to do. And then they generated a polynomial feature for numerical features like size of the house or the age of the house to capture the non-linear relationship. So there's a lot of feature engineering that was done, and that's how they started. Then they got into data processing. They handled missing values by inputting them with mean, medium, and mode values depending on the feature. So for each feature and output, they created those values and found the missing values and imputed them. Then they scaled the numerical features to the similar range to prevent dominance by a certain feature. Remember scaling we talked about? So they scaled. Simple thing was the square feet of the house versus the numbers of the bedroom. They need to be scaled because otherwise the square foot would dominate. So they scaled numeric feature. And then they encoded the category variables using like the one hot coding or the label coding that we talked about. So that's how they did the pre-processing of the data. Then the team went into feature selection, used statistical tests such as ANOVA and mutual information to select the most relevant features that would have significant impact on the target variable. So ANOVA and mutual information was used to select the most important features. And then they applied the techniques like recursive feature elimination. Remember this RFE, where they eliminated the least important feature to figure out to rank the most important features at the top. So that's how they did that. Then they got into reducing the dimensionality reduction. They applied dimensionality reduction techniques like PCA and the T-sign to reduce the dimensionality of the feature space while preserving the important information, and also they visualize the reduced dimensional data to assess the separation of the clustering or the data point. They finally got into visualizing the reduced data. They visualized the reduced dimensional data to basically assess the separation or clustering of the data point. So they evaluated how good was their dimensionality and made sure that they reduced it to minimum dimensions with maximum information that they needed. Then they got into training the machine learning models with techniques like linear regression, decision tree, and ensemble methods using the selected or reduced set of features. Then they evaluated the model's performance using right matrices like mean squared error, mean absolute error, R square score on the validation set and through cross validation techniques. So these approaches they train the model as well as evaluate it. So that's how the training till the training their work carried out. So by identifying and extracting meaningful features, by doing that feature engineering that we have talked about in this lecture from the data and incorporating them into the machine learning model, they could improve the model's predictive accuracy and robustness, ultimately leading to better performance in predicting the price of the houses. So what is next? So having looked at right through to model training, feature engineering, all those things, we are now ready to deploy the machine learning model that has been built, right? So let's take a look at how to deploy the trained model with existing systems and meet the performance requirements. So thank you so much for watching this sixth and the last feature engineering lecture in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question, and also download a PDF file to take it, look at anything that you need to.